Okay, a balancing equations problem. When the following equation is balanced, the coefficient of oxygen is what? Let's make us a little chart here so we can keep up with what's going on each side of the equation. We've got a number of lead atoms, and we've got a number of sulfur atoms, and we've got a number of oxygen atoms. There's one lead, there's one sulfur on this side, and there's two oxygens. On this side, we have one lead. Keep them in the same order so you can compare them. One sulfur, and oxygens we have 3 of. Okay, now what can we do to make these two sides equal? The lead and the sulfur are already the same. So let's start with the oxygen. We have 3 oxygens on the right side, 2 oxygens on the left side. Maybe there's somehow that we could make the right side an even number of oxygens, and then we could deal with it on the left side, because those are always going to come in pairs. So let's put a 2 right here, then figure out what that did to us. 2 leads are what we have on this side now. 2 oxygens and 2 oxygens are 4 oxygens. Good, we didn't make any changes to the other side. Okay, 2 oxygens on one side, 4 oxygens on the other. Seems like we just put a 2 right here. 2 oxygens on this side, make this side have 4 oxygens. Okay, now we need to deal with that lead. Let's put a 2 in front of the lead, and that's going to give us 2 leads, but that also gave us 2 sulfurs. Okay, now the only difference is the sulfurs. What can we do to make the right hand side of the equation the same as the left? Let's put a 2 in front of the SO2. Now, what did that do to us? That gave us 2 sulfurs, and 2 times 2 is 4, plus 2 is 6 oxygens. Okay, let's look back on the left-hand side of the equation. We have 4 oxygens there. If we will just simply make that a 3, that makes that 6 oxygens. And I believe that's balanced. 2 leads on each side, 2 sulfurs on each side, and 6 oxygens on each side.